Thank you for choosing DiQual, and welcome to our podcasts. Before we start, please don't forget to like, subscribe, comment, and share. It is really important to us. Hit that notification button as well, because there is more to come. You can get more detail about DiQual and our courses on our website at www.mydiqual.com. We hope that you enjoy this one.
This section is Security Practitioner 200. Artificial Intelligence, Data Analytics, and Deep Learning. And this is Deep Learning.
Machine learning is a set of algorithms that improve in performance in a given task when more and more data is applied. It is the ability for a machine to learn what the outcome of a particular data set is likely to be, by gathering the statistics and calculating the likelihood of each potential outcome. There are three basic categories in which a machine can learn. These categories are referred to as supervised, unsupervised, and reinforced. Supervised learning. The machine is given a question and a human tells it the answer. Given enough questions, answers and repetitions, the machine will remember the possible outcomes of any given situation and predict the most likely answer. For example, supervised learning for optical character recognition.
Here, in the text, is an image of an optical character recognition process. The image shows a distorted letter that to you and I, looks like a letter D. The software is told that this is a letter D, even though it doesn't perfectly match the template for this letter.
Unsupervised learning. The machine analyzes large amounts of data, and groups similarities into clusters, or distills the data to a smaller amount of relevant information. When new data arrives, it is automatically recognized to fit a descriptor. For example, unsupervised learning for pattern tracking.
At this point in the text, is a screenshot of a video surveillance system. It tracks people from one camera to the next. It highlights the target person with a color, to indicate which cameras they will appear on next. It is predicting where the person will go.
Reinforcement learning. The machine analyzes the input data but also analyzes the response to the output data, to verify that it is correct. The responses build up a statistical likelihood that an output is correct. Reinforcement learning is best described in the scenario of gaming. If the computer wins the game, then it knows it did everything right. The three categories above are a simplistic view of how the algorithms behave. They often combine and overlap to fine-tune the process of accurately predicting an outcome. The combination of different layers of processing is referred to as deep learning. Deep learning is the ability for a computer to take unstructured data and process it in a nonlinear way, using a network of algorithms to create rules based on probability. Neural networks allow data to be processed simultaneously to predict an outcome. Self-learning video analytics. Using a combination of the three categories of learning described here, a system can automatically detect a wide range of conditions or events within video data with very good accuracy.
To demonstrate this, there is an image in the text that shows a busy scene at a shopping mall. It visualizes the video analytics at work by highlighting the scene with yellow markers. The system has detected that some graffiti has appeared on a wall. It has tracked a known individual across the scene. It has noticed that a sports bag has been left unattended. The facial recognition system has identified somebody. The software has calculated that the people on the left have been in the same area for a long time, so they might be loitering with intent to commit a crime. A normal vertical pixel pattern is now horizontal. This may be because somebody has slipped, tripped or fallen over. The software has identified an active shooter on the upper floor. It has also counted 1,628 people in the mall, and 12 of them are dressed in red clothes. Video content analysis goes beyond simple tripwires and direction changes. There are now systems available that can identify features and characteristics of a target. There is another image in the text at this point. It shows a young man in a green t-shirt in a busy street market. The system has identified that he is male. A young adult, wearing a green shirt, and that he is not smiling.
To achieve the recognition of such conditions as shown in these images, the machine needs to make a considered decision based on probability, and/or a recalled experience. If the system can make a considered decision about something, and combine that decision with the results of past experience, then it has the ability to recognize. If it can recognize, then it has at least one form of AI.
That completes this section of audio. We try to keep narration short, because there is a lot of information contained in this section. If you want to, you can listen again, or read the section and switch between text and audio. When you are ready, you can proceed to the next section or subsection within the module.